Okay, so here's my table. I've got it propped up on some books, just 2 books high down the bottom here on this end. It's not propped up at the other end, so that's giving it an elevation at this end of 45 degrees. The table's 180 centimeters or 1.8 meters long. You can work out from that the angle of the slope. Now down the far end here, I've put a line of books to stop the trolley that I'm going to use from falling off the end. There's the trolley. It's going to roll down the slope. And hit the books. And the books are just there to stop the trolley from falling off the edge. At the same time, I'm setting up some different distances on the table for the trolley to roll from. So you'll see I've got a pink sticker quite close to the books. That's my end point. That's where I'm going to measure the end of each run. Then I've got one at 10 centimeters. Overall, I'm going to try and use the whole length of the table, but at the same time I'm going to make sure I've got extra data points at either end, just in case they're important. So I've got 0 and 10. My next one I'm going to do is 30. These are in centimeters. I guess I really should be doing these in terms of meters, so I'm just going to get 0.0, 0.10, 0.30 meters. So each time I'm going to make sure I get these accurately placed using the ruler. I should really have it on the millimeters setting, so I'm trying to get it to the nearest millimeter. In reality, I'm not going to be able to time the cart with that level of accuracy, so the nearest centimetre would probably be plenty on this, but you should usually take readings to the limit of your measuring equipment. 0.30, now I'm going to go 0.60. Each of these I'm drawing a line on, and it's the line that I'm trying to match up with the ruler rather than the whole sticky. Trying to get it just a flat, I might need to put some tape over it. Got this tape to be secure. That line exactly right, and then tape it down. 0.90. So using these stickies is just a way of marking these out so that I can do repeat tests easily. It's not really a key thing that I'd be talking about in my report about the experiment. 1.20, and I think I'm going to go out to about in theory what we're after is like 5 or 6 data points. So I've already got 6. 1, 2. Well, if I don't do 0, I've now got 5. If I have just this one more, I would make it at 1.50. But actually, if I had time to do an extra one or an extra sticky, I would be doing a data point at in here. That's not at 1.20. What am I talking about? You've got it in the wrong spot. There it is. It is 1.20. Okay, and 1.50 is right at the top here. Now, I put that there and then I think about it a little bit, and then I realise that if I put the cart on the table, I can't start the cart at 1.50. So the furthest I can start the cart is actually somewhere around here, like 1.30. So let's modify that, make that 1.30. Okay, so now I've got 1, 2, 3, 4, 5, 6 data points. Two relatively close together at this end. They're probably not too close together. I might just adjust this one out to 1.515. So evenness of your data points, it's nice to keep them even, but in fact, in a non-linear experiment, sometimes there are areas of the graph where you can see the relationship better by having it not even, particularly if you don't measure at one of the endpoints. For example, if we don't assume that there's a 0.0 data point, I mean obviously in this case, in theory, if the trolley starts at the finish line, it's already finished. So in theory, if we run this experiment, we could just have one point where we start and stop the stopwatch. If we start it right here, we can start and stop the stopwatch, and so that's the 0 point. I'm not sure that's a great idea because reactions are a part of doing timing. Okay, now I'm ready to go. I've got my fixed start points. I've got my runway. Now, timing. Got a stopwatch, start, stop, clear. In some ways it's going to be easy for me to do because I can line the trolley up. I can, I'm the one who lets it go. And I'm the one who also stops the stopwatch. So that was 3.79 on the stopwatch, 3.79 seconds from where we go. Now if I do that again, so clear that. I'm just going to try and hold it in a way that I can't accidentally move the cart backwards as I pull my hand away. Oh, I stopped that early. I felt myself stop that early. It's come out as 3.72. I would probably put a little asterisk near that one because I really felt my timing was wrong there. Well, that one came out as 3.72 as well. And that one came out as 3.88. All right, so I've done the first distance at 1.30 meters. Now 1.15 meters. .62 seconds. I think I anticipated that one a little bit, but still 3.62 seconds. .65 seconds. All right, now from 0.90 meters. So you see how I'm lining it up each time looking across? That's to eliminate parallax error. .22 seconds. .22 seconds. .18 seconds. .69 seconds. These are the first runs at 0.6 meters. So 2.69 seconds. Make sure it's running straight down the table. .65 seconds. .72 seconds. Okay, this first run from 0.30 meters. 1.91 seconds. .00 seconds. 1.87 seconds. From 0.10 meters, 1.19 seconds. .07 seconds. And 1.13 seconds. And that's all my data collected. 3 sets of data from each point, 1 extra set of data from one of the points at the beginning where I thought maybe my timing was a bit wonky. Seems pretty good. You can use that data to now fill out a data table.